Hello, and welcome to the third and final portion of section 10.4. Today we're going to look at calculating molecular formulas. We've looked at percent composition and empirical formulas. Now we're going to kind of tie it all in and look at calculating molecular formulas for certain compounds. When we look at finding molecular formulas, what we're trying to do is we're trying to find the actual number of atoms each element has in one molecule of the substance. Remember, an empirical formula was just the ratio of the atoms, the lowest ratio at that. Molecular is going to tell us that we have to have this many to create that actual compound. So in order to do this, we need to determine what the multiplier for the empirical formula is. And to do that, we are going to take the experimentally determined molar mass, which I'll show you how to find, and we're going to divide it by the mass of the empirical formula, which again I'll show you how to find. And that's going to be our multiplier. When we look at example 18, it says a chemical analysis indicates the following. We have 40.68% carbon, 5.08% hydrogen, and 54.24% oxygen. We're told that the molar mass is 118.1 grams per mole. We do need to kind of keep this as a note because we'll use this later on. And we're going to need to find the empirical and the molecular formulas. Well, typically when you have to find the molecular formula, you need to find the empirical formula first. So we're going to use this as a quick review, and then we'll go on to finding the molecular formula. So for the empirical formula, if you remember, we're going to take each of these percentages, and we're going to convert them and assume that they're grams, and we're going to convert them over to moles. So I have 40.68% carbon, and that's going to turn into 40.68 grams. I'm going to multiply that by 1 mole for every 12.01 grams, and this is going to give me 3.387 moles of carbon. And I'm going to go through and do the same thing for hydrogen and oxygen. So as you can see, I end up with 3.387 moles of carbon, 5.04 moles of hydrogen, and 3.39 moles of oxygen. And again, when we go to find the the empirical formula, we have to go and divide by the smallest mole quantity, which in this case is going to be the 3.387. So once I do that, I get this right here is going to give me 1 mole of carbon. This will give me 1.49, so I'm just going to put 1.5 moles of hydrogen. And this here will give me 1 mole of oxygen. Now, I don't have nice whole number ratios, but I see if I multiply this 1.5 by 2, I can get 3. So I'm going to multiply all of these by 2. And what that's going to give me is 2 carbons. Then I'm going to have 3 hydrogens and 2 oxygens. So this is my empirical formula. So if you recall from the previous slide, I said that we had to find that multiplier. And with the multiplier, we need to find the experimentally determined molar mass and the mass of the empirical formula. So here, we're going to take our experimentally determined molar mass, which if you recall was 118.1 grams per mole, and that was given to us in the problem. And then we have to find the mass of the empirical formula. So the mass of the empirical formula, I'm going to say carbon is going to be 2 times, and carbon was 12.01 grams per mole. Hydrogen, we said that we have 3. We're going to multiply that by 1.008 grams per mole. And then we have our oxygen, which is 2 times 16 grams per mole. So when I multiply these out and I add all of these up, we end up with 59.04 grams per mole. So now we need to find our multiplier. And we're going to do that by taking that 118.1 grams per mole, and we're going to divide that by our 59.04 grams per mole. If you notice, our units are going to cancel, and this is what's going to give us the multiplier, and we are going to end up with a multiplier of 2. So what that means is I'm going to take my empirical formula, which was C2H3O2, or this right here, and I'm going to multiply all those subscripts by this multiplier of 2. So my molecular formula then, so I'll put molecular formula, is going to become C4H6O4. And this is the molecular formula. And now for our final example, it says a chemical analysis indicates the following. We have 74% carbon, 8.65% hydrogen, and 17.35% nitrogen. Okay, that is nitrogen, not oxygen. I did make that correction. We're told that the molar mass is 162.26 grams per mole, and we want to find the empirical and molecular formulas. Okay, I would recommend at this point in time that you please pause the video, try to do this on your own, and then come back and see if you get the correct answer. The first thing we're going to do is we're going to find the empirical formula, and we're going to do that by taking the percentages that are given and write those down as grams and convert to moles. So here you can see I took all the masses, I divided by the molar mass, and I ended up with the moles of carbon, hydrogen, and nitrogen. Now I'm going to divide by the smallest mole value, which in this case is nitrogen, or 1.24. So after I do all the math, I end up with roughly 5 moles of carbon, 7 moles of hydrogen, and 1 mole of nitrogen. So my empirical formula then will become, oops, let me switch over to the pen, C5H7N. And again, this is my empirical formula. We now need to find the molar mass of this empirical formula. So I have 5 times, and carbon is 12.01 grams per mole. Then hydrogen is going to be 7 times 1.008 grams per mole. And nitrogen is just going to be 1, and that is 14.007 grams per mole. So when I multiply these and then I'll add them all together, we will end up with, so I end up with 81.113 grams per mole for the empirical formula. So now to finish up the problem, we have to find that multiplier. With that multiplier, we need the original value, which from the example up here, you can see it was 162.26. We'll see if we can slide all this up. So I have 162.26 grams per mole. And I'm going to divide that by what we just calculated, which was 81.113 grams per mole. And when we divide those, we end up with a multiplier of 2. So that means I'm going to take my, and I know this got kind of messy, my C5H7N, and I'm going to multiply each one of those coefficients by 2, and that will give us C10H14N2. So this here is our molecular formula. Please let me know if you guys have any questions. Otherwise, have a great day.